Welcome back to my class. In today's class, we will see the usual and standard form of a decimal number, and we will also see that how we can convert a decimal number from standard form to usual form and from usual form to standard form. And we will also see at the same time that how we can use exponents, be it positive exponent or negative exponent, to express small numbers in standard form. So let's start the class. Now here we have a few exercises that we will simplify definitely. But before that, let's have the concept what we understand by usual form and standard form, and how we can convert from one form to another form. Now the number here that is given 602, and after 602, if we count the zeros here, we have total 13 zeros after 2. So this form is a usual form. A decimal number is given. Now standard form is, suppose if we take the small number like 602, if we take, then this is the usual form of a decimal number. And standard form is that form where before decimal point we have one non-zero value. Now 5.17, this is also a decimal number, and this form is the standard form where before decimal point we have one non-zero digit, and that is 5, and after decimal point we may have any number of digits. Now for 602, if we take this example, then it may apparently seem that where is the decimal point? 602, there is no decimal point. Basically the decimal point is after the last digits, or the digit that we have at unit place. So 602 can be thought as 602.0. Now if this 602 or 602.0, if we want to represent in standard form, then what we have to do? Standard form means it will look like something 6.02, and there will be something else. So 6.02, that means this decimal point, instead of after 2, it will be after 6. So we can say that this decimal point basically will move towards left, and this time it will move by 2 places. From here it will move here, and then it will come here. So before 2 it will come, so it will be the movement of 1 place. Then after that it will come before 0, so it will be movement of 2 places, and then 6.02, it will look like a standard form. But what we have to do, what adjustment we have to do if we express as 6.02 or the standard form? The rule is, when the decimal point will move from right to left towards left, then we will multiply by 10 to the power n. And when the decimal point will move from left to right towards right, then we will multiply by 10 to the power minus n. Here this plus n and minus n, n represents the number of places by which we are moving the decimal point. So here 602.0, and we want to finally represent in this format 6.02. So decimal point is moving by 2 places towards left. So what we will do with this standard form, with this number, we will be multiplying this factor 10 to the power then n, and n is what? The number of places. So here we are moving by 2 places, so it will be 2. So this is the standard, this is the usual form, and this is the standard form of that 602. Basically these two have the same value. 602, here it is 6.02 multiplied by 100, 10 to the power 2 means 100, and 6.02, when it will be multiplied by 100, what value it will give us? It will be 602 only. So basically this usual form and this standard form have the same value, but this is the way how we can convert from one form to another form. Now suppose we have another example, like the second example that we took, 5.17. Now what form it is? it is given in standard form. Now suppose we want to express this standard form, this value in usual form. Now means we will convert from standard form to usual form. So usual form means the decimal point will be at the end. Standard form means decimal point will be after one digit, right? So that means when we will express this 5.17 in usual form, this will look like 517, and then there will be some other factor because of that adjustment what that we will do. So 5.17, so what we are doing is we are moving this decimal point towards right. And how many places we are moving? We are moving by 2 places. So 517, then what factor we will be multiplying? Since this time we are moving towards the right, so it will be, the factor will be 10 to the power minus n. That means 10 to the power minus n. And what is the value of n this time? Again we are moving by 2 places, so it will be 10 to the power minus 2. So basically 517 we are multiplying by 1 divided by 100. That means 517 we are dividing by 100, and if we divide by 100 517, it will be 5.17 only. That means the standard form and this usual form, they again have the same value. Now let's solve a big examples of the values. So here 602, and as I said, after 2 we have in total 13 zeros. So one way we can think this way, that 602 and since 13 zeros, so we can express this way, 602 into 10 to the power 13, but this is not the standard form. The same value we are representing, and both are them have the same value. So but from this usual form we want to represent in standard form, and standard form means before decimal point, this decimal point is usual form, so that means we have the decimal point after the last digit. So it will be like this, it can be thought as like this. So this decimal point will be moved towards left, and before decimal point in the standard form we will have one digit. So how many places it will be moved by? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Then decimal point will come here, so it will be 6.02, and since it is moving towards left, so it will be multiplied by this factor, and n is how much? N is 15 that we have already counted. So it will be 6.02 minus 15. This is the standard form. Now let's proceed with this. Here what we have, here the exponent is positive exponent, the base is 10. Now here we have 0 point and then 1 2 3 4 5 6 7 8 9 10 11 zeros, and after that we have 3 more digits, 9 4 2. So 12 13 14. In total after decimal point we have 14 digits. Before decimal point we have 0, but this is 0, this is not a non-zero digit. So this is usual form, and we will represent the same number in standard form. So when we will represent this in standard form, so this decimal point will move towards right, and how many places it will move by? 1 2 3 4 5 6 7 8 9 10 11, and then 9. So that means 12. Then this 9 is placed at 12th position, so this decimal point will come here, and when it will come here, before decimal point it will get one non-zero digit, so it will stop here. But how many places it will move by? It will move by 12 places, this decimal point. So that means the value will be 9.42, and to get this value, this standard form 9.42, the decimal point has moved towards right by how many places? 12 places. So when it is moving towards right, so the factor that we will be multiplying by, it will be 10 to the power minus n. Always the base will be 10 and minus n. So minus how many places we have counted? That is 12 places. So it will be 10 to the power minus 12. So this is the way how we convert from usual form to standard form. Now we will solve another set of problems, that is from standard form to usual form we will convert this time. So it is given 9.61492 10 to the power 6. It is given in the standard form, and we will represent in usual form. So usual form means this decimal point will come at the end, and when it will come at the end after this 2, after the digit that we have at the unit place, this decimal point will move definitely towards right. Towards right means what we did. Towards right means we will be multiplying by 10 to the power minus n. So just remember that. And this will be multiplied by 10 to the power minus n, and we already have this factor 10 to the power 6, and here it will be this decimal point will move 1 2 3 4 5 places, and then we will get this value 361492. And by how many places it moved? It moved towards right by 5 places, so it will be minus 5. Since it has moved towards right, so it will be minus n, so minus 5. So it will be written like this, and then further it will be 361492. Fine. And 10 to the power minus 1 and 10 to the power minus 6. So what we know, that a plus b, it will be 10 to the power minus 5, 10 to the power plus 6. So it is like a to the power n and a to the power m. So it will be a raised to the power n plus m, that means minus 5 plus 6. So it will be 10 to the power plus 1 only. So it will be 10 only. The power is plus 1, so it is 10 only. This is the usual form, and further we can write this way: 361492 and then 0. So this is better. This looks better. This is the usual form. Now the next example is 3.25 10 to the power minus 7. So as we know, when we will convert the standard form in usual form, then it will look like 325, and then after that we will assume there is the decimal point. So this decimal point is moving towards right by 2 places. So since it is moving towards right, so it will be multiplied by 10 to the power minus n, and this time 2 places, so it will be 10 raised to the power minus 2, and already we have this factor 10 to the power minus 7. So finally it will be 325 then multiplied by 10 to the power minus 9. As we know this formula, this law, so it will be n plus m, so minus 2 plus minus 7, so it will be minus 9. Now this is not yet complete. 10 to the power minus 9 means 325 will be divided by 10 to the power 9. So this time, this at the end we have this decimal point. So if we want to remove this factor 10 to the power minus 9, then this decimal point which is located at the end, this will move towards left, right? So towards left, and how many digits? By 9 digits, 9 places. So it will be 325, then we had this decimal point after 5. Now it will move, to remove this factor, the decimal point will move towards left, because when it will move towards left, I will show you, it will move by 9 places. So 1 2 3, then 4 5 6 7 8 9, and then this will be, here we will have the decimal point, and before decimal point we will have another 0. And since this time the decimal point has moved towards left, so towards left means we will multiply by this factor 10 to the power n. So 10 to the power n, this time how many places it has been moved by? 9 places. So it will be 10 to the power 9, and we already had one factor which was 10 to the power minus 9. So this will cancel each other, and definitely we will adjust such a way that this factor will be cancelled. So since it is 10 to the power minus 9, so we should have here another factor which is 10 to the, which will be 10 to the power plus 9. And to get this factor, we should move this decimal point from n towards left. And 10 to the power 9 means it will be moved by 9 places. So 3 2 5 3 places, and then we will add 6 more zeros, and then we will have here the decimal point. And this is the final usual form of this value. Next we have 1.0001 and 10 to the power 9. So how to express this in usual form? This is standard form. So 10 to the power 9 means we have to cancel this 10 to the power 9. So at the end we have 10 to the power 9, and if we want to really cancel this factor 10 to the power 9, then we have to multiply by 10 to the power minus 9. Then it will cancel each other. And if we want to have this factor, then we have to do some adjustment on this number so that we get this factor. And when we get this factor, we get this type of factor where we have negative exponent when the decimal point moves towards right. That means in this number which is given in standard form, this decimal point will move towards right by 9 places. So it will be 1, then we already have after decimal point 4 values, 4 digits, so it will be this, but 9 places it will move. That means we will have extra 5 zeros. Already after decimal point we had this number, and since the last digit was non-zero, so we should consider this 3 zeros also in between. So this was after decimal point, the 4 zeros, 4 digits that was already given in that number, and then 9 places we have to move the decimal point, so extra 5 zeros we will add, and now here we will have the decimal point. So this is the usual form, and then with that we will have this factor, we will multiply, and then already we had this factor, so this will cancel each other and only this value will remain, and that is the usual form of this value. So it will be 1 0 0 1 and then 5 zeros. So this is the final answer, this is the final usual form. Next we have one other problem sum. It says that if the diameter of sun is 1.4 into 10 to the power 9 meter and earth is this, then respectively, and then they compare their diameters. So for sun the diameter is 1.4 multiplied by 10 raised positive 9, and for earth the diameter is 1.275 10 raised positive 7. This is meter and this is meter, and we need to find the ratio of their diameter. So sun, the ratio of sun and earth will be simply the ratio of these two values, 1.4 10 raised to the power positive 9 divided by 1.275 10 raised to the power positive 7. 1.4 and 10 to the power 9 can be further written as 10 to the power 7 and 10 to the power 2, because again that formula 10 to the power 9 means it can be thought as 10 to the power 7 plus 2 means n plus m, so it will be 10 to the a to the power n and a to the power m, right? So 10 to the power 7 multiplied by 10 square, 10 to the power 2, and then in the denominator we have 1.275 and then 10 to the power 7. This factor is common in the numerator and denominator, so they will cancel each other, and that's why we splitted this 10 to the power 9 factor, as we wanted to cancel this factor from the denominator, and since 9 was greater than 7, that's why we did this adjustment in the numerator. Otherwise we would have done in the denominator if this power, this exponent was has had the higher value than the exponent in the numerator. Anyway, then what we will do next is simply we will take the ratio of this 1.4 and 1.275, and then that will be multiplied by 10 square. So if we simplify this value, then it will be 1.098, then it will be multiplied by 10 square. So 10 square means, if this is a standard form, and if you want to know the usual form of this value, if we want to represent in, then this 10 square has to be removed, and if we want to remove this 10 square, then we have to multiply by 10 to the power minus 2. So this will cancel each other. And now from this number if we want to represent as a number multiplied by 10 to the power minus 2, then what we have to do, this decimal point we have seen earlier, this decimal point will move towards right, and by how many places? Since this time it is 2, so it will move towards right by 2 places. So decimal point will come here and they will cancel each other, and the final value will be 109.8. It is approximately 1/10. That means the diameter of sun is 110 times higher or more than the diameter of the earth. So this was the explanation of standard form, usual form, their conversion, how we can use exponent to express small numbers in standard form. I hope the whole idea is clear now to you and you can solve any type of problem related to this. So with this, I end today's class. Thank you.